Another type of constants are constant variables. So we can make a variable like this one constant by putting const, the keyword const, before the variable definition. So different from the constant defined by macros. So constant variables, they are indeed variables. So which means that they require memory and also they have types. And in this example, we are using the address of this constant variable buffer size. So constant variables defined like this are not that useful. So the most common use of constant variables are constant parameters, like defined in this example. And here the constant variables means that constant parameters means that this function will not make any changes to the values of these parameters. So here const means that in this function we are not going to make any modifications to this parameter emp1, and this const means that in this function we are not going to make any modifications to the values of emp2. And within this function, and if we do make changes to that, the compiler will not let it go. For example, in this function, if we change the name of this employee, and let's take a look whether it will compile or not. You see, it cannot be compiled. So typically in large-scale software development, the interfaces are defined by the architect, and the implementations of these interfaces are done by the programmer. Those are the implementations. So by specifying that the parameters of function are constant, the architect can ensure that the programmer will not modify the values of these parameters. And also for the clients of those classes or functions, by reading the interfaces, that they will know that this function will not modify the values of these parameters. For example, this main function is the client of this function, which means that it's using that, and you can see that we are passing these two objects, John Smith and Alex Stowe, to this function, and because these two are constant, these two parameters are constant, then we know that this function will not make any modification to the values of these two objects, John Smith and Alex Stowe. So in this example, this is passing by reference. So you can see this, they have this ampersand indicate that this is passing by reference. So passing by reference means that essentially this John Smith and the emp1 point to the same object. They are pretty much similar to passing by a pointer. And passing by reference, if within this function, if we are not going to make any modifications to the object, then we should always use const to indicate that, then which makes your program much easier to read and also prevent you have typos to accidentally make some changes to the objects. And note that passing by value is totally different. So passing by value means that this if we do not have this ampersand here, then this will become passing by value, and passing by value means that this object and these two are totally two different objects. So essentially they will, when we call this function, this John Smith object will be bit by bit copied to this object, and these two will be point to two different objects. And for passing by value, if we use const, it's not that useful, but for passing by reference or passing by pointer, then we use const, means a lot. And here is a corner case. So if a data member is specified as a constant, then it can only be initialized through the member initialization list of the constructor, because we cannot perform assignment, and we do need to initialize those data members in the constructor. And the initialization list is used like this. You use colon and the name, the data member, and parentheses the parameter. And the meaning of this is to use this parameter to assign to the data member.